When I first saw it, I thought that this was a US-made, very advanced next-generation fighter, and in fact that this would explain all the UFO sighting. It was only later to find out that that wasn't the case.
What if one strange clue from the past suddenly fit into place today? Think about that for a second, because this story takes a surprising turn the moment a forgotten device shows up again. People who thought they already knew the full tale are now asking themselves questions. Who would not? Could this mysterious sphere be the same type Bob Lazar described decades ago? Or is humanity staring at something far stranger? 1. The discovery. On March 2nd, 2025, people in Buga, Valle del Cauca, Colombia, recorded a round, shiny object moving across the sky. Clips taken showed a smooth metal ball moving low over streets and fields. They appeared on social media platforms within hours. People rushed to see what had happened out of curiosity. Someone picked up a small metal sphere from a grassy area near the road. Reporters also reached the site within a flash of a second. Mexican journalist Jaime Maussan helped in spreading the news. He invited other reporters, technicians, and a few researchers to broadcast the incident. Technicians placed the sphere on a table and moved it using gloves. The crowd watched as they displayed X-ray images on screen. The images showed bright shapes inside the round shell. Presenters pointed to a small central object in those images and to several small round pieces around it. Later reports showed different numbers for those pieces. Some images showed 9 inner beads, while other images showed more, raising many questions. During the presentation, Dr. José Luis Velázquez shared a little about the images, as engineer Rodolfo Garrido explained parts of this device. Researcher Carlos Muñoz described how the images were taken. They said the outer shell looked smooth with no visible seams. A short clip showed someone pouring water on the sphere that produced a pale vapor. Cameras recorded the small cloud. Reporters collected statements that said plants near the landing spot looked damaged. A few neighbors said they felt sick after touching or standing close to the device. Those health reports appeared in interviews, but no formal medical report was shown to the public at that time. Videos from the site showed the recovered sphere wrapped in cloth as it was being removed from that place. Those clips helped track the chain of events, but did not replace lab records. A clear paper trail would list who took the item, who stored it, and when it moved to the laboratory. Different journalists quoted different weight and size descriptions from presenters at the event. Some said the object felt heavy for its size. Others said it felt light. The stage commentary used words such as core, shell, and beads to describe what appeared in the images. Despite being discussed at the site, the public still needed test results to verify those claims. Video clips and pictures taken that day pushed the story onto international news. People compared the images to old claims about secret projects and unusual power devices. They also posted side-by-side images and thoughts. Technicians warned about rushing to conclusions. The media attention brought more people to question the object, to record more images, and to ask who would test it next. Authorities secured the scene for a short time while videos kept circulating. Within a day, the device was already the topic of discussion everywhere. The reporting by Jaime Maussan drew media attention. Media coverage described the sighting, the recovery, and the first public images. Questions from reporters at the event helped enlighten people, leading to others asking questions about possible danger. Some asked how labs would test the object and what could happen afterwards. So far, the scene had film footage, a reporter, and members of the public as witnesses. This object, as strange as it is, made people ponder OT. Do you have any idea of who handled the sphere after recovery, which labs would run the tests, and when the open test results will appear for the public to see? But what secrets lie within its mysterious core? Could this tiny sphere hold clues that defy explanation and challenge science itself? 2. Lab tests. The images shown in that day's presentation raised many questions. The team on stage showed X-ray images and scans. They pointed at layers in the shell and talked about a small core inside the ball. Presenters also talked about many tiny round pieces around that core and the bright color coming from the device. Some steps had to be followed in the laboratory. First, laboratories record who handled the object and when. This record is a chain of custody. It shows the path the item took from the field to the laboratory. Without such a record, it is hard to trust the results, therefore raising the authenticity of the lab reports. Second, laboratories inspect the surface with a microscope, which tells if the item was cast, molded, or machined. Machined parts often have small marks from cutting tools. Cast parts have grain patterns that look different. These signs help technicians tell how something was crafted. Third, lab technicians run X-ray fluorescence tests. X-ray fluorescence is a quick test that shows which elements sit on the surface. Elements are basic building blocks of matter. This test does not destroy the object, as it gives a fast readout for metals such as iron, aluminium, titanium, nickel, and copper. If the object shows common metals, then that is a normal result. If the object shows rare mixtures, technicians will take more samples for deep tests. Fourth, laboratories may use mass spectrometry. Mass spectrometry reads tiny bits of matter to name exact atoms and isotopes. An isotope is a version of an element with a different number of neutrons. Some isotopes last a long time. Others break apart fast. Known heavy elements made in laboratories usually last only for a short time. If a test shows strange isotope ratios, that would be notable. It would require more testing by other researchers. Fifth, laboratories use electron microscopes to look at tiny structures. Electron microscopes show details that a light microscope cannot see. These machines can show crystal shapes and thin layers. They can also reveal coatings that hide marks. If layers exist, laboratories can slice a tiny piece and study the cross-section to see how the layers join. Sixth, laboratories may run gas tests if vapor was seen. Gas chromatography is a way to separate and name gases. It can say if the vapor was water, oil, a chemical, or something else. If a test shows toxic gas, laboratories alert health authorities. If the vapor is water vapor from heat, that gives a simpler explanation. I hope we are together up to this point. Do not get lost. Ask questions if you have any. Seventh, laboratories measure radiation and fields. Radiation counters show if the object emits particles. Magnetometers measure magnetic fields. Small heat sensors can indicate tiny temperature changes. If an object emits energy that normal tools cannot explain, technicians add more sensors and repeat the work. Eighth, laboratories may weigh and measure density. Density is mass divided by volume. Knowing density helps match a material to known metals. For example, iron is heavy for its size. Aluminium is light. If a mass and volume do not match known metals, that is a reason to test more. Laboratories also may open the object if rules allow. Controlled disassembly happens under strict safety rules in a clean room with protective gear. Technicians label each part and test each part on its own. If the item has wiring, sensors, or familiar electronics, that will show quickly, and if no wiring appears, technicians look closer to see if some parts are bonded in other ways. At the scene, the images shown were not backed by full laboratory reports in the public records. Specialists shared with the crowd, but they did not publish raw data files that technicians use. Without raw files, outside teams cannot repeat the tests easily. Neutral research groups often push for open methods. Open methods mean laboratories publish methods, settings, dates, and raw data so others can check the work. That process helps the broader scientific community evaluate results. Without open methods, claims will never go beyond mere talk. What would change the public view? First, open laboratory reports from a laboratory. Second, repeat tests done by more than one team that reach the same results. Third, a clear paper trail showing who handled the item and when. These steps move a claim from a stage show to a verifiable record. Many technicians use simple tests early on. For example, they may rub the surface, take pictures, and run a quick X-ray fluorescence scan at first moment. They also take small samples under supervision and store them in sealed containers labeled with the time and date. These samples become the basis for deeper research. If a sample shows regular metals and clear machining marks, the case becomes less strange. If tests show unusual isotope ratios or materials that do not match any known alloy, more researchers will join. The work then becomes a broader effort. Some researchers said they would accept samples under strict protocols. The public wants those teams to act and show the full test records so anyone can check them right away. Who will run those open tests and share every raw result with people around the world? Yet, as the world waited for proof, cracks in the story began to emerge. Could these results really be trusted? 3. Skeptics. Many scientists and researchers reacted to the news by asking for open tests before accepting such claims. Some experts said the images were interesting, but there was not enough proof. They pointed to gaps in the testing process shown on stage. One major issue was the paper trail that tracks who handled the object. Scientists want a clear record that shows who recovered the item, who stored it, and when it was moved to a laboratory. A sealed chain helps rule out tampering. That record was not shared on the day the news broke out. Another issue was the variation in the images themselves. One slide showed 9 small round pieces inside the shell. Later images showed a larger number. That change made many people ask for the raw scanner files and the original images. Raw files let other technicians check the same data. Skeptics offered simple explanations for what was seen on the screens. The object could be a piece of art. It could also be a machine component, such as a bearing or a sensor housing. Many industrial parts use inner balls for balance. A smooth outer shell can be produced by casting or molding. Those images alone cannot rule out these common causes. Scientists urged more testing by reliable laboratories. Research centers usually follow strict methods and publish full test records. Those records list which machines were used, the dates of testing, and the exact settings. They also share raw result files so other teams can review the numbers. That open method makes results easier to check and trust. Claims about health and soil also needed proof. Some people said crops near the spot looked damaged. Others said they felt unwell after coming into contact with it. Medical checks and soil tests can examine these reports. Doctors and environmental laboratories can test blood, air, and soil for chemicals or radiation. If tests show no unusual results, concern will ease, and if tests show odd results, more work will follow. The presenter, Jaime Maussan, has a long public history. He has promoted several unusual objects before. Some of those earlier objects were later questioned by outside researchers. That past led many scientists to tell people to wait for neutral lab work before concluding. Groups such as the Galileo Project were suggested as partners for open testing. The Galileo Project aims to study unusual objects using public methods. An open approach means full data release and repeated tests by different teams. That way, many experts can look at the same numbers and check the results independently. Media coverage affects public response. Short social clips and reaction videos spread fast. That speed made it hard for accurate testing to keep up. Scientists warned that quick headlines can push them to release partial results. Solid testing takes time and many steps. What do skeptics want first? They want surface scans, element checks, and isotope tests. They want high-resolution images from electron microscopes. They want gas analysis if vapor was reported. They want dated photos and sealed sample bags. They want labs to publish raw files and full methods. Only then can the discussion move beyond stage remarks. Several researchers signaled willingness to examine samples under strict protocols. They require sealed submission forms, agreements, and dates before testing. Once laboratories accept samples, they record each stage, take duplicate samples for other scientists, and publish full reports so anyone can review the raw results. Who will step up now? But then something unexpected happened. A new object appeared, echoing decades-old claims. Could this sphere finally reveal truths scientists once dismissed? 4. Lazar Link. The moment the sphere was presented on stage, many people brought up one name right away: Bob Lazar. His claims go back to the late 80s, but they still get attention today. The new sphere reminded many viewers of the objects he once described while talking about his work at a facility he called S4, near the United States military base at Groom Lake. Even though his story has always been debated, the similarities were strong enough that people started comparing the two cases. So, what made people connect this sphere to Bob Lazar? Let us break it down. Lazar said he worked on a propulsion system that used a compact power source. He described it as a small, solid object that sat inside a larger housing. According to him, this device did not have moving parts. It also did not have wires or fuel lines. He said it could create a powerful form of energy when placed in the right position inside a craft. These details may be questioned, but they are the same points that people noticed when they saw the inside of the newly presented sphere. People compared the inner ball structures shown on the scans to drawings that Lazar had made in the past. In his older interviews, he sketched a round system made of layers. The sketches showed a central part surrounded by other pieces. The new sphere looked similar in shape. Even though no one can say they match, the visual likeness started a big discussion. Something else made the link stronger. An early image of the sphere's scan showed 9 small, round pieces inside. Later images showed a larger number. This change confused scientists, but it reminded many viewers of how Lazar said the device he worked on had a pattern of small pieces arranged inside it. He said they were placed in exact spots and could not be moved without breaking the whole thing. Again, this does not confirm anything, but it is one of the reasons people kept asking if the sphere could be an object with a related purpose. Another part of Lazar's claims was about the material. He said the device he worked on used a very heavy type of metal that was hard to produce. When the new sphere was tested on stage, they said it had metals that were common on Earth but arranged in an unusual way. They did not share enough lab data to confirm this. Even so, viewers compared this to Lazar's older statements about materials that looked normal at a glance, but behaved strangely. People also brought up Lazar's comments about how the device reacted to strong scanning machines. He once said that high-energy scanners could affect how the object behaved. During the recent news, one of the scientists said their scanning machine could not penetrate the sphere at first. They had to use a different method to get the interior images. That detail added more fuel to the conversation because it matched what Lazar once talked about. Some viewers pointed out one more link: size. Lazar said the device he worked on was small enough to lift with both hands. The sphere presented in the recent case also looked small and easy to hold. Both objects were described as dense. Again, the match does not prove anything, but it is important. Of course, many scientists warned the public not to jump to conclusions. They said that similarities do not mean both objects have the same origin. Despite that, the link to Lazar kept trending online because the shape, the layers, and the solid inner pieces sparked memories of his older interviews. What makes this connection interesting is how it mixes confirmed information with old reports that have never been verified. The sphere is real and was physically shown on stage. Lazar's device is known only through his own words. That means we have one physical object and one verbal description. The comparison must be done carefully, or it can mislead people. However, the overlap is enough to raise fair questions. Did the sphere come from a human-made device? Is it part of an old machine? Could it be a natural formation? Or is it something built with a purpose we do not understand yet? Those who support Lazar believe this could be a modern example of what he described years ago. Those who doubt him say the similarities are surface level and can be explained without his story. What makes this moment important is the next step. If a research center accepts the sphere for full testing, we may finally get real data about its material, age, and origin. That data will help confirm whether the Lazar comparison is worth keeping, or if it should be dropped completely. For now, the door stays open. And that leads to the big question. If full tests match even one part of Lazar's old description, what will happen next? Thanks for hanging out with me today. If you enjoyed this, remember to like, comment, and subscribe. More stories coming soon.